Welcome to Project Management. This presentation covers Chapter 22, Project Management, from Ian Somerville's book, Software Engineering, 10th edition. We all have used the term project at one time or another. You have had school projects, maybe you have participated in the house remodeling project, or have worked on a project to fix your car. First, a project is unique. This doesn't mean that different projects cannot produce similar products, but rather each project has variation to it that it has to be addressed and controlled. These variations will come in the form of constraints such as budget, schedule, resources, and quality goals. A project is a sequence of unique, complex, and connected activities having one goal or purpose that must be completed by a specific time within budget and according to specification. So what is project management? Um, Software project management is concerned with activities involved in ensuring that software is delivered on time and on schedule and in accordance with the requirements of the organizations developing and procuring the software. Project management is needed because software development is always subject to budget and schedule constraints that are set by the organization developing the software. The focus for a project manager in a software project is not primarily on the technical aspects of the project. That is the focus of the project team. The focus for the project manager is more aligned with the business aspects of the project. We already have noted that for a project to be successful, it must deliver the expected business value. This is the focus of the project manager, and the project manager's realm of influence are on those things that affect the business value of the project. The figure on this slide is an adaptation of a concept first formalized by the Project Management Institute called the iron triangle or triple constraint. Originally, the three slides of the triangle were cost, schedule, and scope. Scope defines the work that will be performed and the product produced by the project. The concept is a simple one, but forms the basis for all project management activity. A change in any of the three sides of the triangle will cause a change in one or more of the other sides. For example, to add more scopes to the project will require addition to cost, schedule, or both. If there's a desire to reduce the cost of the project, then we will either have to compress the schedule or eliminate some of the scope. Then goal of project management is to keep these three attributes in balance in order to produce the desired solution or product. This slide expands upon this initial concept to represent the total focus of the project manager. The project objective is to deliver a solution or product defined by the scope that conforms to a defined quality. The project manager controls the cost, schedule, and resources required to achieve these objectives. The project manager must also be aware of project risks and be prepared to adjust these project's parameters should the risk be realized. The team develops the solution or product that conforms to the scope and quality objectives, while the project manager is responsible for bringing the team together and directing the team to achieve the technical objectives of the project while providing the team the time and resources necessary to accomplish the project objectives. The project manager does not work in a vacuum to execute the project or controls all these parameters alone. It has been said that a project manager has full responsibility for project success, but no authority to get it done. The project manager usually has control over the project schedule and the utilization of resources, but other project stakeholders control the other project parameters. Company management will control the project budget or cost and what resources are given to the project. The project's customer will control the project scope and quality goals. Risk management. So what is a risk? A risk may threaten the project, the software that is being developed, or the organization. Risk management involves anticipating risks that might affect the project schedule or the quality of the software being developed, and then taking action to avoid these risks. Risk management is concerned with identifying risk and drawing up plans to minimize their effect on a project. Software risk management is important because of the inherent uncertainties in software development. These uncertainties stem from loosely defined requirements. Requirements changes due to changes in customer needs, difficulties in estimating the time and resources required for software development, and differences in individual skills. You have to anticipate risks, understand the impact of these risks on the project, the product, and the business, and take steps to avoid these risks. Risk management process involves 4 stages: risk identification, risk analysis, risk planning, and risk monitoring. Risk identification help identify project, product, and business risk. Risk analysis assess the likelihood and consequences of these risks. Risk planning draw up plans to avoid or minimize the effects of the risks. Risk monitoring monitor the risk throughout the project. Risk identification is the first stage of the risk management process. It is concerned with identifying the risks that could pose a major threat to the software engineering process, the software being developed, or the development organization. Risk identification may be a team process in which a team gets together to brainstorm possible risks. At the same time, project managers may identify risks based on their experience of what went wrong on previous projects. As a starting point for risk identification, a checklist of different types of risk may be used. 6 types of risks may be included in a risk checklist. Estimation risks arise from the management estimates of the resources required to build the system. Organizational risks arise from the organizational environment where the software is being developed. People risks are associated with the people in the development team. Requirements risks come from changes to the customer requirements in the process of managing the requirements change. Technology risks come from the software or hardware technologies that are used to develop the system. Tools risks come from the software tools and other support software used to develop the system. During the risk analysis process, you have to consider each identified risk and make a judgment about the probability and seriousness of that risk. There is no easy way to do so. You have to rely on your judgment and experience of previous projects and the problems that arose in them. It is not possible to make precise, numeric assessment of the probability and seriousness of each risk. Whether you should assign the risk to one of a number of bands. 1. The probability of the risk might be assessed as insignificant, low, moderate, high, or very high. 2. The effects of the risk might be assessed as catastrophic, serious, tolerable, or insignificant. The risk planning process develops strategies to manage the key risks that threaten the project. For each risk, you have to think of actions that you might take to minimize the disruption to the project if the problem identified in the risk occurs. You should also think about the information that you need to collect while monitoring the project so that emerging problems can be detected before they become serious. In risk planning, you have to ask what if questions that consider both individual risks, combinations of risks, and external factors that affect these risks. Based on the answers to these what if questions, you may devise strategies for managing the risks. Finally, you should have strategies in place to cope with the risk if it arises. These should reduce the overall impact of a risk on the project or product. Risk monitoring is the process of checking that your assumptions about the product, process, and business risks have not changed. You should regularly assess each of the identified risks to decide whether or not that risk is becoming more or less probable. You should also think about whether or not the effects of the risk have changed. To do this, you have to look at other factors, such as the number of requirements, change requests, which give you clues about the risk probability and its effects. These factors are obviously dependent on the types of risk. You should monitor risks regularly at all stages in the project. At every management review, you should consider and discuss each of the key risks separately. You should decide if the risk is more or less likely to arise and if the seriousness and consequences of the risk have changed. The people working in a software organization are its greatest assets. It is expensive to recruit and retain good people. It is up to software managers to ensure that the engineers working on a project are as productive as possible. In successful companies and economies, this productivity is achieved when people are respected by the organization and are assigned responsibilities that reflect their skills and experience. People management factors include consistency, meaning team members should all be treated in a comparable way without favorites or discrimination. Respect. Different team members can have different skills, and these differences should be respected. Inclusion. Involve all team members and make sure that people's views are considered. Honesty. You should always be honest about what's going well and what is going badly in a project. As a project manager, you need to motivate the people who work with you so that they will contribute to the best of their abilities. In practice, motivation means organizing work in its environment to encourage people to work as effectively as possible. If people are not motivated, they will be less interested in the work they are doing. They will work slowly, be more likely to make mistakes, and will not contribute to the broader goals of the team or the organization. Most professional software is developed by project teams that range in size from 2 to several hundred people. However, as it is impossible for everyone in a large group to work together on a single problem, large teams are usually split into a number of smaller groups. Each group is responsible for developing part of the overall system. The best size for a software engineering group is 4 to 6 members, and they should never have more than 12 members. When groups are small, communication problems are reduced. Everyone knows everyone else, and the whole group can get around a table for a meeting to discuss the project and the software that they're developing. A manager or team leader's job is to create a cohesive group and organize that group so that they work together effectively. This task involves selecting a group with the right balance of technical skills and personalities. Sometimes people are hired from outside the organization. More often, software engineering groups are put together from current employees who have experience on other projects. Managers rarely have a completely free hand in team selection. They often have to use the people who are available in the company, even if they're not the ideal people for the job. Group organization. The way a group is organized affects the group's decisions, the ways information is exchanged, and the interactions between the development group and external project stakeholders. A major challenge facing project managers is the difference in technical ability between group members. The best programmers may be up to 25 times more productive than the worst programmers. It makes sense to use these super programmers in the most effective way and to provide them with as much support as possible. At the same time, focusing on the super programmers can be demotivating for other group members who are resentful that they're not given responsibility. They may be concerned that this will affect their career development. Furthermore, if a super programmer leaves the company, the impact on a project can be huge. Therefore, adopting a group model that is based on individual experts can pose significant risks. Group communications. It is absolutely essential that group members communicate effectively and efficiently with each other and with other project stakeholders. Group members must exchange information on the status of their work, the design decisions that have been made, and changes to previous design decisions. They have to resolve problems that arise with other stakeholders and inform these stakeholders of changes to the system, the group, and the delivery plans. Good communication also helps strengthen group cohesiveness. Group members come to understand the motivations, strengths, and weaknesses of other people in the group. To sum it up, good project management is essential if software engineering projects are to be developed on schedule and within budget. Software management is distinct from engineering management. Software is intangible. Projects may be novel or innovative with no body of experience to guide their management. Software processes are not as mature as traditional engineering processes. Risk management involves identifying and assessing project risks to establish the probability that they will occur and the consequences for the project if that risk does arise. You should make plans to avoid, manage, or deal with likely risks if or when they arise.